Okay, hello everyone, you're welcome to today's class. So today I'm going to be introducing a topic titled differentiation. So in this topic, I'm going to be explaining like the various derivatives, a table containing the various derivatives. And also I'm going to solve one or two examples as introduction to differentiation. So I said this table here contains the derivatives. So y, which is equal to f of x, then my dy over dx is equals to f prime of x. So this is my function y. My y is same thing as my function x. Then my dy over dx, that's my differential of my y to respect to dx, is still the same thing as my differential of my function x, which is f prime of x. Now, I move to the table now. Constant, this constant could be any number. It could be 1, 2, 3, 4, 5, like that, not 0. Now, if I have a constant number and I'm differentiating, the differential is 0. Now, so that's that. If I have x raised to the power of n, an algebraic function raised to the power of n, it's the same thing as me bringing down the power, which is n. I'll bring down the power to multiply the function, which is x raised to the power of the power minus 1. That's why I have differential of x raised to the power of n. I have it to be n x raised to the power of n minus 1. The next one is exponential function. Differential of e raised to the power of x is same thing as e raised to the power of x. Then differential of kx, that's e raised to the power of kx, is same thing as me bringing down the constant, and I'll have the constant multiplied by the same, what I'm being given, which is e raised to the power of that constant multiplied by x. That's why I have k e raised to the power of kx. The next one is ln x. Now, the differential of ln x, which the ln x is the same thing as log to base e x. So the differential, I'm going to have it to be 1 over x. Then here I have my sine x, which is trigonometric function. This the ln x is logarithm function, while here I have my trigonometric function. So for my trigonometric function, differential of sine x, I have it as my cos x. Then differential of sine kx, I have it as k cos kx. So that's that. Then differential of my cos x is minus sine x, and differential of my cos kx is minus k sine x. Then tan x, differential of my tan x is sec square x, and my tan x is the same thing as sine x over cos x. So the differential is sec square x. Then tan kx, as you all know, is k sec square kx. So that's the differential. So I move to the other part of the table. Now, so this table is very, very important. You master it very well, because all the calculation or that we're going to be doing under differentiation, you have to master the table. So let's proceed to the next table. Now, the next table here, I have cosec x. So if I'm differentiating my cosec x, it's the same thing as me having minus cosec x cot x. So my cosec x is the same thing as me having my minus cosec x cot x. Then here I have sec x. The differential of sec x, I have it as sec x tan x. Then here I have cot x. Differential of cot x, I have it as minus cosec square x. Now, so this table is very important. You understand, like you know them, that they are basic differentials. So from the table now, I'm going to apply what's on the table to solve one or two examples here. So my example one, they say I should differentiate the following. Now I have the first one, which is a solution. I have a is equal to a. I have y is equal to x raised to the power 5, and I'm asked to differentiate it. So if I'm differentiating this with respect to dx, I'll have dy over dx is equals to dx raised to the power 5 over dx, which will give me, as I said earlier, this is the same thing as me having x raised to the power of n. So my n here now is 5. So me having 5 now, all I need to do is to bring down the power multiplied by the x raised to the power, the power which is 5 minus 1. So I'm going to have it as 5x raised to the power 4. So that's my final answer. So I move to the next one, which is b. B says I should find y is equals to sine 5x. Now you see, the constant here I'm being given is 5. The constant here is 5. So I'll have my dy over dx is equal to d sine 5x over dx. So my differential of sine 5x, just like I said from the table, I say if you are differentiating sine and you have a constant that is k multiplied by the same thing as that constant multiplied by sine, the constant times x. So the constant here now is 5. So I'll have 5, which is my constant, multiplied by my sine, the constant times x, which is this. But here, I'm not going to have sine because the differential of sine is cos. Now, so I'm going to have 5 cos, the constant times x, which is 5 cos 5x. Now, so the last one now, which is c, say I should find my y is equal to e raised to the power of 2x. So differential of exponential function. So I'll have my dy over dx is equal to differential of the exponential function to respect to dx is equal to me having, now I have 2x. This 2 here is a constant multiplied by x. So all I just need to do is just to pick the power, which is 2x, and I'll differentiate it. Now, differential of 2x is same thing as 2. Differential of 2x is same thing as 2. Then I'll use it to multiply the exponential back. So differential of 2x is same thing as 2. So I'll have 2 exponential raised to the power of 2x. So that's my differential. So the differential is 2 times exponential raised to the power of 2x. So that's that. So I hope you all understand. I hope all the table and the question that is being solved under this introduction to differentiation is clear, and hope to see you in the next class, whereby I'm going to be taking the various techniques that are being used in differentiation. So thank you very much and have a nice day.